Welcome everybody. Today is a fifth class for C++ London Uni. My name is Tom Breza and I'm one of the hosts. Other two hosts are Tristan and Oliver, and as well we using sometimes this fella there, Justin, plus extra few people. So first of all, thank you much for coming. I do appreciate. I hope you will enjoy today's class. A couple of things for you to get you going. As you may know or not, our meetup is pretty much 100% volunteer run. So none of us gets paid. We're doing this as in a way of helping everybody. So obviously, in order to make this project sustainable and success, so it continues not only today but next year and so on, we need to make sure this project have a way of working out. So how can you help? Yes, obviously we don't want you to pay for the classes as you would normally go to the commercial projects for different reasons. Yes, we want to be open to as many people as possible, but obviously we need to find a way that this project will work. So what could you do? Yes, how can you support our project? Well, there are a number of ways. First one is we have prepared a couple of memory sticks. This is more for people who, I mean, for anybody, but if you have, let's say, a machine and you can't start, let's say, an operating system with ID and be able to run the operating system on it and ID, you can use this one. That's a live USB. So you can start it, you can have full operating system run from the USB and use it. By buying this, yes, we recommend the price, let's say £15. Our cost for the memory stick is something like £7. So if you want, that's one way of basically supporting us. Another one is we're running the page, which I hope Tristan will bring the address.
I haven't done it this week.
There is a GoFundMe page. We are collecting money. We're trying to get the money for a replacement laptop for Tristan, because pretty much he uses the most of the laptop for preparing slides. Yes, so preparing the classes and obviously running the classes. And unfortunately, his laptop died. So I think 1/3 way, but obviously we need a little more money. So if you find beneficial to you, help us.
Should probably point out that that's a loaner. That's a loaner with a dead battery.
Yeah, this one needs.
So
doesn't do so well.
We're not forcing anybody to do anything, spend any part with your money. This is not about that. But obviously, if it helps you and you feel like, oh, these guys did something good to me, I feel, I would like to contribute, help them. Please do. Another one is after the class, and this is from me, from my side. After the class, we're going to pub. Join us, and even if you don't want to stay, buy these guys a beer and some food. So at least they spend the whole day getting here, doing the work for you. So at least we send them home happy with full belly and beer. Finally, on the same subject, if you know anybody, yes, any company who would like to be a sponsor of C++ Uni, just let me know. Yes, send them into my directions. Maybe somebody wants to put a banner or put something on our website. We're open to that. If we can get money, then we don't have to do anything else. We don't have to think of how we pay lots of costs and so on. So that's from that side. On our website, we want to put a section which is called Success Story. So if you benefit from us, yes, I don't know, you got a new job, you got a promotion or something, or even just we give you a refresh and we give you more confidence where you approach for, I don't know, some promotion. If you would like to share your story, come to me. What we would like to do is put your picture and short story, how did we help you? Because when we're looking for sponsors, yeah, so we've been talking to a couple of big guys like Facebook, Sky, King and so on. Frequently they want to say, okay, so who did you help? Well, we've got lots of people, but do we help anybody? Oh, you don't have anybody? Goodbye. Yeah. So if they see real faces of you, then their wallets will open more, eagerly, and obviously we can be here. Then next one, for people who are new, our class are weekly. So today on Tuesday we have a lecture where Tristan, with help of Oliver, they basically pass you the material. After that, we have on Thursday we have a workshop. So today is just to pass you the knowledge, and Thursday is very important. It's basically for you to try, because when they explain, everything seems extremely simple, but when you sit actually in front of IDE, it's not so simple. And the best way to do that is basically exercise. And if you have a group of people who do that together, it's way easier. If you want the latest updates, follow our website, cpplondonuni.com. Follow me on Twitter. My Twitter Twitter name is xxbms.
What does it mean?
Doesn't mean anything. I just looked for a free thing. It just something like this come up to my mind, and I did it. Now I have a batch of new licenses. If he remembers, good. If you need a license, please do email me. Subject line Sea Lion license. Inside the body, put your name, surname, and your email address, and I will email you back the 6 months extension to the license. RSVP. Lots of confusions. How does it work? If we have a class or a workshop in Skills Matters, you have to RSVP at Skills Matter website. We don't care then if you RSVP on our website. Yes, because Skills Matters prints those badges, and if it's too many people, they'll just cut. If it's not enough people, they will put us in a small, like a small room there, like a cupboard, yes? So if you want the big room, please do RSVP quicker. If the class is, if the lecture, like class on Tuesday, is on the Mimecast or somewhere else, RSVP on our website. Mimecast doesn't have the facility for RSVP, so we have to provide them with the list of people who is coming so we can print badges and let you inside the building. Otherwise, the insurance will say no, and you won't get inside. On Thursday, if we have the workshop in Costa, which is just the other side of the street, please do RSVP on our website. Why? Because we're trying to get some sort of, some experienced developer to commit their time, again, unpaid, so they need to know that there is somebody coming. Because imagine somebody, like caliber of Tristan or Ollie says, okay, I will spend the evening helping people, gets there, gets his coffee, and there's nobody there. He'll be quite angry. So help yourself, RSVP on our website. And after the class, obviously we're going to pub, so join us. That's all from me. I'm passing to Tristan. Thank you very much. Sorry it took so long.
All right. Good evening, everybody. Thank you for coming along again. I'm glad we're not in the broom cupboard again. I hope it didn't put too many people off all being cramped in last week. Just a few faces I don't recognise. Who's here for the first time tonight? 1, 2, 3, 4 of you. Hi. Okay, so you can, as you see, you dropped in at week 5 of our little course. So there's a little bit of catching up to do. So if you want to, and I'd encourage you to, all the previous slides from the last 4 weeks, in fact, a lot further back than that, but the last 4 weeks of this course are on our GitHub repository. And also all the videos, so all the sessions are recorded, go out live on the internet, and they're also recorded, and they're all available on our YouTube channel. So if you just search CPP London Uni, C++ London Uni rather, on YouTube, you can find all of these previous sessions. So that's, hopefully you'll be able to catch up using that. And then if you've got any more questions, feel free to bother us with them. This is, again, mostly for the new folks, because everybody who's been here for the past month has seen this several times already. We have this Slack channel that we encourage everybody to join. So Slack, for those who don't know, is this sort of chat program, but you can use it through your browser as well. There's a CPP Lang group on Slack for just discussing everything about C++. And we have our own room in there, this #CPP London Uni. So if you go to that URL, it'll ask you to put your email address in. Let's go to that, you can sign up, and then we can chat on all the time we're not here. And everybody else who's been here for the past few weeks is absolutely fed up with me saying this, but I'll go through it. All right, so last week we covered quite a lot. We talked about value semantics. C++ is a value semantic language by default anyway. Means more or less that copies are distinct. So if you copy a variable and you change the source, you change the original, it doesn't affect the copy. So that's a bit different to how some other languages work. It's quite intuitive when you think about it, but it can be quite new to some people who are used to other languages. Talk about pass-by value. That is, when you pass a value to a function, then by default the function receives a copy of whatever you pass it. So if the function changes that argument, it doesn't affect the value that was passed to it. And we talked about these ideas of scope and object lifetimes, so how these two things are tied together. So in C++, object lifetimes are for the most part are controlled by the scope in which that object lives. So you can't access something outside its scope. Once we leave the scope in which the variable was declared, that variable is destroyed. This is an extremely powerful idea. It's the basis of how we do memory management and all sorts of things in C++. And it's sort of quite an important thing to get a good handle on, right? Because C++ doesn't use garbage collection, unlike most other languages. We use this idea of scope-based lifetimes to control to clean up after ourselves. And then finally, we got on to talk about just some basic control flow. We started talking about if statements. The way they work in C++ is pretty familiar. If you've used any other programming languages, if statements work in basically exactly the same way. Say if the condition is true, you enter the branch. And then you can have else if statements, as many of those as you like. And then if you want, you can have a final else branch. So again, if you've done any sort of programming, if is probably quite familiar. This week, we don't have quite so much on the menu. We're going to talk about the other basic control flow method, which is loops. And then we're going to go on to talk about references, why they're important, const references as well, and pass by reference. So we talked about pass by value last week. This week we're going to be talking about pass by reference, because C++ actually supports both. So that's what's on the menu for this week. Homework from last week. Who had a go at that? A few of you, good. Who succeeded?
I didn't do all of them. I succeeded with most of them.
Okay, so this was last week's homework. So for the homework exercise, by the way, I have said this a couple of times, but just to reiterate, I deliberately go a bit further than we have in the lessons, right? Because the idea is that these sessions, we can't give you a complete introduction to the language. We just don't have enough time. Right? Well, 2 hours a week is not really enough time to fully get you well versed in C++. So the idea is that with these homework exercises, it goes a bit further than what we've done in class. So you're going to have to do a bit of reading for yourself, whether that's from a textbook or online resources, whatever your preferred method is. So for these exercises, you actually had to use loops and you had to use vector and things we hadn't actually introduced in the class yet. But now, so who of the, what was it, 5 or 6 of you put your hand up? Who managed to do part 1? Okay, everybody, 2? 3? The last one? Sort of 2 people. Oh, excellent. Okay, so it's confession time, right? I wrote this out and I thought, okay, well, we'll do the mean and the median, that's nice and easy. And then I had it in my mind how we do the mode. I thought, oh yeah, I know how to do that. And then I came to actually do the solutions. And it turned out that this was a lot less elementary than I thought it was. And it's actually a bit harder than I intended it to be for an introductory exercise, right, for week 4 of the class. So if you did this, very well done. If you didn't, then don't worry too much about it. Don't beat yourself up, because this was harder than I thought it was going to be when I initially wrote the question up. So the solutions, or at least the solutions to the first three exercises, because I haven't put the solution up to the fourth one in a way that I think is nice and easy to understand. So my method uses lots of horrible advanced parts, so I need to kind of simplify it so that it sort of doesn't confuse people, confuse anybody who looks at it. If you go to that URL, you'll find my solutions. I will put up a solution to exercise 4. As I say, I need to find a way of doing it nice and simply that I haven't done yet. So we can have a quick look at those now, if you want to. Otherwise, you can have a look at your own time. Which would you like?
Let's have a quick look.
You want to have a quick look? Okie dokie. This nice dark theme that the new Mac OS has is very, very dark on this projector, isn't it? But anyway, let's have a look at this. Okay, so this is so the solutions are on separate branches because I wanted you to start off with something basic and then extend your program. So part 1 was that I wanted you to read in a sequence of numbers and then print the maximum and the minimum number. So have a quick look at that. So I just gave a little prompt to enter some numbers. And then we set up variables to hold the minimum and maximum that we've seen so far. Now this is not something that's particularly obvious. This is how you get the largest possible double value. And this is how you get the smallest possible double value. So numeric limits is something that's part of the standard library. And you can say numeric limits of a double, and then we want the minimum value. There is also there's a C constant. It's called something like DBL underscore min. Underscore min, yep. You can use that as well. That's perfectly fine. This is just sort of showing off that what's the proper C++ way to do it. But if you use double min and double max, that's absolutely fine.
Isn't the min minus max? You've got the min. Isn't the min minus to the minus 308, not to 0, not to the.
Oh, have I got this? Have I done the wrong one?
I did exactly the same thing.
I may. You may be right. I may have messed up here. I'm going to have to double check that, because there are two values. One is that there's the smallest possible value that's greater than 0.
Yeah.
So times 10 to the minus whatever. And there's one that's the lowest possible, so minus a very, very big number. And I think this is the lowest possible number, not the smallest value that's greater than 0. I think.
Can I ask you something? Because we were using the same. But if you now, before inserting any value, you print, do you have any number there?
Yes. So if we don't enter any values whatsoever, it will print these numbers out.
And if you enter one value, it will still print one value and one of the two.
Well, let's have a look. So we start off. We create. So this is our sort of variable just to hold the last value that was entered. Right. So then we have this while loop. We're going to have a look at while loops and exactly how they work. But basically, we continue reading in numbers until the user enters something which is not a double, is not a number. So if the number they entered, D, is less than the current minimum, then we update the minimum to be that value. So the first time through the loop, let's say the user enters 0. So it's going to say, is 0 less than this, less than min? Well, min has been set up to be the greatest possible double value. So anything they enter is going to be less than that. So then the min is going to be the number that they entered.
To answer your question, it is the smallest possible value above 0, smallest possible positive value.
Oh, so I got it wrong.
Yeah.
Oh, well, there you go.
I did exactly the same thing.
Right, I shall change that before.
So So what is the right declaration?
Yeah, what is the correct one then, Ollie?
Minus max.
Just did it say that before I opened my mail. Oh, interesting. The lowest final value. Yes, so you call lowest instead of min.
It's called lowest, is it?
Yeah, I mean, let's run it and test it.
Well,
So let's change that.
it's confusing because for int, min is
And that is a very big negative number, yeah.
Okay, so it's lowest and not min. Is the other one highest? Is there a corresponding highest? Because that would make sense.
So that's very cool.
Okay, well, there you go. I can make mistakes as well. Okay, so imagine that didn't say min. Imagine that said lowest.
Well, I mean, obviously there is technically positive and negative infinity, but
I don't think you can parse that using cin.
Do we have to initialize the variable?
Do we have to initialize this variable here?
The minimum and maximum variables?
Do we have to? Well, that's an interesting question.
Because, like, as I done, I heard this thing about the minimum variable, and I got confused on that. I say, okay, let's do like this is my fourth lesson.
Yeah.
And I get the minimum and maximum variables without initializing. In the first reading, both of them get that value, whatever it was.
Yeah.
And then the while loop started. That was easy. Now, is this like a C++ way of doing it?
Okay,
It's
so
better-
so if we don't initialize these values, or then what happens is if we try and read from them, so they will be filled with random junk. Okay, it could be anything. It's just whatever bits happen to be lying around in memory at the time. So technically, we're not allowed to read from that value. Okay. Now, if you do, what's going to happen is you're going to get effectively a completely random number, and whether or not this value they entered is less than some completely random number, well, sometimes it's going to work and sometimes it won't.
First instruction is assign the value. My first instruction.
To
Once I created it, I tell them assign the first value that you read.
to me, okay, no, that would be a valid way of doing it. If you're assigning to it before you read from it, that's okay.
The first reading that I do, the first number.
Okay, that
they
would-
enter,
That would be a fine way to do it. Yes, that would be absolutely fine. As long as you are writing, as long as you're assigning a value before you read from it, that's okay. That would be fine actually. Yeah, you could. As an alternative to doing this min and max or highest and lowest or whatever it should be, you could special case the first run through. So the first value sets min and max, and then you enter the while loop. That would be a good way to do it actually. So yes, we set min and max. And then we print out the minimum and the maximum. So as we go through this loop, every time it compares the number you entered to the current minimum and the current maximum and prints them both out.
You need two different values before this works, right?
You need,
Two different values before.
well, no, the first time you enter a value, it's going to update min and max. So the
If I enter
first,
11,
sorry?
if I enter 11, for example.
Yes. So it's going to say,
First print out, yes.
is 11 less than my minimum value? And since we set min to start off with as the highest possible double, so 11 is certainly going to be less than the highest possible double.
So minimum would be 11. What about the maximum?
Highest possible.
Yeah, so, well, I mean, I made a mistake, so this should be lowest, but what we actually wanted was to set max to the smallest possible double value, right? So 11 is certainly going to be greater than than the lowest possible value. So so the first time you go through the loop, min and max will both be set to 11, assuming the user entered 11.
To also elaborate on that, IEEE 754, which is obviously what's implemented by pretty much everything, does have positive and negative infinity. So to make this truly correct for your platform, for a standard PC, just use positive and negative infinity.
Is that actually typed in capital letters infinity?
No, if you want to use the macro, yeah, but numeric limits has a way of you just call dot colon infinity.
Okay.
Anyway, apart from my mistake with this is the sort of solution. But as you say, you could do it slightly differently by first reading one value in order to set min and max, and then entering the loop. That would be a perfectly fine way to do it.
I was going to ask you, the while what I got sort of started going in random direction was sort of an escape character or key. Or
Yeah.
and I tried to build that in, and then I said 0, so I could enter 0 as a value, because I said users can escape the loop
Yeah.
with a 0.
Yeah, so another way to do it would be for example, you could
So
read.
where would this break?
So this breaks as soon as the user enters something that can't be converted to a double. So you just put a yeah.
character. Any
Yeah. Another way to do it, if you wanted to be a bit more
so
fancy.
the while loop conditional statement deduces that only doubles are accepted.
Exactly that, yeah. So as I
You
said,
don't need to spell it like literally verbatim, spell it out like not equals. Something.
so a fancier way to do it would be, for example, you could get the user to enter a string, and then you could have a look at that string, and if that string is quit, then you exit the loop.
Yeah.
I tried this one, but how can you put the string inside a double variable?
So there's a function, what is it, S2D, which converts a string to a double.
I used to peek.
Peak.
So you can look at your, because the seeing is, not reading about it, is always a string. So you can look at the string before you sign your
What you're peeking is when you look at the string without consuming data from the string.
And then you can sign your int or whatever after you've done your peek.
Yeah, but why would you not just use the operator, the shift operator, but just write it into an int and then check if bad bit's set?
Because it might be a string.
No, what I'm saying is if you try to put it in, it should set. It sets a flag.
Okay, so exercise 2, I asked you to print out the mean, that is the sum of all the values divided by the number of values, the average, or one type of average. So in this case, this is our main. I don't know what those blank lines are doing there, bad formatting. So you can see main is now a little bit simpler because we've moved the min and max calculations outside of it. So we've got this variable to hold our running total, our last value entered, sorry. And then we've got a vector of doubles to hold all the values. So all we do is, while the user keeps entering doubles, we're just going to pop them all into our vector. Push back pushes a new value into the back of the array. And then we print out the maximum, the minimum, and the mean. So min and max are just as they were. Again, I got that bit wrong, so I'll change that. That should be lowest. But this is effectively exactly what we were doing before. We're just running straight through the loop. So this is a range for loop, which we're going to talk about today. And now, for our mean calculation, we have a variable to hold the sum. We run through the entire vector, adding every entry into the sum, and then we return the sum divided by the size of the vector. That's the number of elements that are in it. Yes?
So, what if somebody wants to write out like a sequence and feed it in one go? Is this possible? Because at the moment they're kind of putting in one number at a time.
Yes, so this cin will discard all the white space. So if you could, it'll read from standard in, but using the console, if you're familiar with sort of Unix shell, you could pipe a whole load of values into standard in, and as long as they're separated either by spaces or by tab characters or by new lines, there's some type of white space in there, then cin will get rid of that white space and consider those as separators. Yeah.
I mean, if you were looking for the ultimate efficiency, you'd ask the user how many values they want to give you. Then you would get the vector to pre-allocate space for that many values, and then just ask for them and place them.
So yes, so as I say, this time we're holding all the values in a vector. Now, technically, there are clever ways you can calculate the mean as a sort of running thing rather than summing them all up. There is a formula for that, but if you did that, bonus points. But
For the max, was it literally the same as the last one? Or is it, no, it's a range. It's a
so I'm using this range-based for loop. We're going to talk about that just in a few minutes, in fact. So what this does is for every value in the vector, it assigns it to D. If D is greater than our current max, then we set the current max to D. So it's exactly what we were doing before, except I've put it into its own function this time.
Have you done const yet?
Yes.
Should have made it const.
Which bit?
19 const order.
Yes, I could have. And finally, exercise 3, I asked you to get the median. So the setup is exactly the same. In fact, main is identical to what it was. Just added this get median function. There are many ways that you can get the median. This is a way that is quite simple. I mean, it's not a lot of code. It's not necessarily the most efficient way of doing it because there are ways of getting the median without sorting the entire vector. There's a function called nth element that will do it for you. But this has the bonus of being only a few lines of code. So the thing with the median is that if we got an odd number of things, then when we sort it, it's the one in the middle. If we've got an even number of elements, then it's halfway between the two. So if we've got 4 elements, then the median is halfway between these two. And if we've got 3 elements, then it's just the one in the middle. So that's what these two if and else branches are doing. So the middle index is the size divided by 2. Size returns you an integer, so this is floor division. So if we have an odd number of elements, say we had 3 elements, then vec.size is going to return 3. 3 divided by 2 is 1.5, but it rounds down, so it becomes 1. And then we remember that C++ counts from 0, so element 1 is actually the second element. So that's the one we want. So we just return the middle index of the vector. And then in the else branch, we do exactly the same, except we take the average of the 2 middle elements instead. So do people get something like that? Yeah, a few nods around the place. As I say, my implementation of mode ended up being very complicated, so I haven't put that up there. But I will.
Did you use a map? Just like interesting.
I did indeed use an unordered map, and then extracting if the mode is not unique. If the mode is unique, it's relatively easy, but handling multiple possible indices. Yeah, that was what I was trying to avoid, looping multiple times through the thing. I thought I knew how to do that when I was writing the question, but it turns out that head intuition is not necessarily accurate. So anyway, that was last week's homework. So well done to those of you who managed it. As I say, it's up on that URL if you want to have a look at it in your own time. I will correct my buggy solutions, which is slightly embarrassing, but hey, there you go.
That's feature. That was a feature.
No, it was definitely a bug. So I'll correct that, and I'll put up, when I come up with a simple solution to the mode, I'll put that up there as well. So that was that. So if you did that, well done. Otherwise, let's move on. Let's talk about something new. Well, something we've just touched on there, but we're going to investigate in a bit more detail. Let's talk about loops. Okay, drink. So I said, last week we looked at if statements. So if statements are a pretty fundamental element of every single programming language. It's if some condition is true, do this. It's equally fundamental is this idea of looping, of doing things multiple times. Right, in fact, if statements and loops are pretty much the two things you require for a Turing complete language. They're essential for a programming language that can do anything meaningful. So a loop tells the program to continue doing something, repeat some operation, while some condition is true, while some condition holds. So if you've used any sort of what we call curly brace programming language, C-derived programming language, the loops that we have in C++ are going to look pretty familiar, right? Because C++ inherited them from C, as did Java and C# and JavaScript and all these other languages. So hopefully nothing I'm about to say is going to be particularly mysterious. So first of all, we've just had an example of one. We'll talk about while loops. While loops are probably the simplest form of loop. Well, I reckon they are the simplest form. So we use the while keyword. And a while loop just looks like this. It's while some condition is true, execute the thing in these curly braces. So some condition, so C++ has a Boolean type, a value, a true or false. So some condition, whatever you put in there, it will be converted, or the compiler will try and convert it to a bool value. So for an int, for example, 0 is false and anything else is true. And the same for float and other types. So standard, so cin, for example, standard in that we just looked at, that's rather special because it has a specially defined conversion to bool that is, if everything is okay, if I read a value from the stream correctly, then it returns true when converted to bool. Otherwise, if there was an error, if it couldn't convert, in our case to double, then it returns false. So that's why we did the extraction in this while loop. Just as with if statements last week, technically you can put any single statement after the while. You don't have to. You don't have to use curly braces, although it's good form to put them in there. Right? Technically, we could just put one line in there. We've got one statement to play with. If we use curly braces, that opens a new scope, so we can put multiple things in. So you will sometimes see people just omit those and put one line. Probably not very good form.
If you didn't put the braces in, then would the scope, so the variable scope rules then not exist for that statement? For that part within, there would be no scope until it gets to large.
That is incorrect. Okay, so if you omitted these curly braces and you used your one statement that you have to initialize a variable, that variable scope is as if you had put the curly braces in.
Okay.
Yeah.
So is that true for all loops? Like
And if statements as well. Yes, all of them. So that's another reason why it's a good idea to put the curly braces in, because it makes the scope very clear and obvious.
Right. But then another thing is that alone, sort of that variable or that value will only exist for that one iteration of the loop.
Yes, exactly that, yes. So if you want to declare, if you want to have a value that lasts outside the loop, you have to declare it outside the loop. So this is this scoping and lifetime idea that we were talking about last week. So the program keeps repeating the instructions inside these curly braces for as long as some condition is true. So what happens is that our program gets to here, it tests whether this is true. If it's true, we execute this code, we get down to here, and then it jumps back up, jumps back up to the top and tests the condition again. If it's still true, we execute it again, and again, and again, and again, until some condition returns false.
I know the answer, but I'm going to ask. What if I wanted to execute a loop just at least once, guaranteed? Are you about to cover that?
It's an interesting question, that. Yeah, so if the condition evaluates to false the first time we go through, we never enter the loop. Okay, so it's possible that we execute this 0 times. So this is a nice and simple, the simplest form of loop. very slightly more complicated is what Ollie was just asking about. Being a smart-ass.
Power prediction.
It's something called a do-while loop. So this is very, very similar to just the basic while loop, except this time it looks like this. So I have this keyword do something whilst this condition holds. So in this case, what happens is that our program comes down, it comes to here, it executes this, and then it checks the condition. And if the condition is true, it loops back up here and starts again. And again, and over and over and over. So the difference between a while loop and a do while loop is that in a while loop, the condition is checked first, and in a do loop, the condition is checked afterwards. So the difference between the two is that with do, the body of the loop, that is the bit between these curly braces, is guaranteed to be executed at least once. In practice, do-while loops are relatively rare. Like, it's good to know that they exist, but they don't get used very much compared to plain while loops. Also, it's weird that do is a key word in C and C++, but this is the only place in which it's used. I think do is like a very useful word to have, right? But this is the only place in which it's used.
Sorry,
Yeah.
there's a do while. There may be a silly question, but is there a while do?
No.
Okay.
So it's just while body.
How don't.
Sorry? Don't.
Don't.
No.
Don't.
No, neither can you do not do, unfortunately.
Yeah,
Do-
it's another lesson.
Do not do blank. They're all keywords in C++. You could write it, but the compiler wouldn't like it very much. Okay, so for loops. Who knows what a for loop is? Most of you, not everybody. Okay. So a for loop, I'm going to go out and say, is probably the most common type of loop that you will see if you're looking at other people's code. And it has this, one more, has this rather strange syntax, this thing in 3 parts. So this is inherited from C. Java has this, and C#.
I wouldn't put increment, I would just say post statement. You don't have to increment.
No, it's just the most common thing to do, right?
Yeah.
Okay, so a for loop comes in 3 parts. First of all, we have this initial statement, then we have the condition, and then what I've called increment here. Ollie's saying that's not strictly accurate. It's the post action. Most typically, it will be an increment of some counter, but technically it doesn't have to be. You can put any old statement you like in there.
Or nothing. They're all optional, actually.
So what happens here is that when our control hits this statement, the first thing it does is execute this init statement. So I've called it init because what it will typically do is initialize a variable, like a loop counter. After that, the condition is checked. And if the condition is false, we immediately leave. So just like a while loop, condition is false, we skip the body completely and carry on down here. If the condition is true, we enter the body of the loop. We execute it all, and when we get to here, it performs this action, this third part, which I've called increment. But as I say, technically you can do anything you like. But what we'll typically do is we'll increment this loop counter. So by far the most common way to do this is that you'll set up some sort of counter in your init. Your condition will be, well, if my counter is less than some maximum value, and then your increment will increment the counter. And we keep on doing this. So init is only run once, but we test the condition, execute the body, do the post increment step, over and over and over again until the condition becomes false. So to show you a slightly realistic example, what's this program going to do? Okay, this is going to print out every integer from 0 to 9. Okay, so what we're doing here. Our program begins at main, as it always does. The first thing is it hits the for statement. So it'll execute this, which means it creates a variable named I. And that I remains in scope for the entire duration of this for statement. Not just for one loop, but for the whole time we're executing this entire loop. So we'll initialize this, and then it checks, is I less than 10? Well, we've just set it to 0, so it's certainly less than 10. And then we execute the body of the loop. So we'll print I is 0 and a new line. We reach here, and then it executes this third statement, I++, which is increments I. So I was 0, I++ means that I is now equal to 1. At this point we jump back up to the top and we test this condition again. Is I less than 10? Well, I is 1, so that's less than 10, so we execute this. We increment I again, so now it's 2. It's 2 less than 10, yes it is. So we execute the body, and so on and so on and so on. And eventually we print 9, and then we increment I. At this point, I becomes equal to 10. So now we jump up here, and we test the condition. So I is equal to 10 now. Is 10 less than 10? No, it's not. So at that point, our loop is completed. We skip the execution, and we jump down here, and we do whatever else is in the program, which in this case is nothing at all. So this is a really, really, really common thing to see in C++ programs, C programs as well. This 3-element for loop.
It's probably worth pointing out that you can do exactly the same thing with a while loop. It just requires more lines of code.
Yes. Every single for loop that you write like this, you can write out as a while loop. And you can have a bit of a think about how you might do that. You think about initializing a variable first, checking a condition, and then incrementing, performing this post-loop step. So it looks a bit weird when you start off with, but you very, very quickly get used to this pattern. One mistake people will often make early on is they will expect 10 to be printed. That won't happen. The condition gets checked before we enter the loop. So this prints 0 up to 9, gets to 9, it increments the counter. Is 10 less than 10? No. So then we exit the loop. Yes?
I have a question about the while loop.
Oh, right, yes.
In this case, the I is just within the scope of the for loop. Right?
Correct, yes.
In the while loop, you have to initialize it outside of it.
That is correct. That is correct, yes.
So I guess it is slightly different.
Yes, but C++ allows you to create a scope wherever you like, just with a pair of curly braces.
Right.
So that's the way you would do it. You create a scope, declare your I, do the while condition, and then, yes.
Yep.
So particularly, as I say, you can do pretty much whatever you like in any of these three, more or less any C++ statement is acceptable in the 3 parts. But this thing of initializing a variable, testing it, and then incrementing it is overwhelmingly, like massively, the most common way you will see this done. Technically, you're also allowed to omit any of the three parts. You can just put a semicolon. If you omit this condition, then it's as if you had just written true in there. So it will just continue and continue and continue forever.
Does it have to be less than, greater than? You can't do an equal. So.
You can absolutely do equal. So any statement, so the middle, just like the condition of a while loop, this has to be convertible to a bool. Right.
What I mean is, can you do I is less than or equal?
Yes, no, yeah, you absolutely could, yes. Yeah.
So if you admit any of those, you can just assume it would be true, true, true.
Yes. Semicolon, semicolon, force, so yeah, it's just infinite loop.
Yeah. And finally, we've seen the horrible form of for loops, or, well, not horrible, very useful, but slightly ugly. There is a much nicer form of for loop as well. It's what we call a range for loop. If you're familiar with other languages, you might call this for each. But in C++, it just uses the same keyword. And what this is for some declaration, and then a colon, and then some range of values. So this range is, you can think of it like a protocol. It's formally called a concept. Anything that meets this range concept can be used in a range for loop. In particular, a vector. In fact, all of the standard library containers. So strings as well. So when you use this range for loop over a vector, it will run for every element in that vector. A string you can think of, think of it, it is like a container of characters. So this will iterate over every character in the string. So to give you a little example, here I'm declaring a vector. It contains the values 1 to 5. Now we're saying for every int I in vec, print I, followed by a new line. So this is slightly different from the 3-element for loop that we just looked at, because in that case, the first statement, the init statement, whatever variable we declare there, that is in scope for the whole duration of the loop. Whereas in this case, a new I comes into being for every iteration. So the scope of I, you can think of it as being inside the loop. So it's slightly different from the 3-element form we just looked at. So this is it's not just one I that we declare once and then update its value. I gets initialized every time.
Isn't it strictly calling plus operator on it because it's stop again basically, right? Is it the same object?
No. No, it reinitializes. It does.
It's just got plus plus.
It does int I equals star begin, and then it updates begin in the loop. That's, you can look it up. There's actually
there's a translation. Yeah.
Is it making a copy of each of the elements in the vector?
Yes, it is. Yes, it is. So every time we run through, we'll copy whichever the next element is. We'll copy it into this new variable I. That's a very good question. Yes. Yeah. So this will copy that into a new element I, copy that into I. So every time we run through, we're creating a copy of whatever element we're looking at. So for int, we don't care. Int's are very cheap. That is, it doesn't take a lot of CPU time to copy an int.
So you said for the for range, the range for loops, the i's all repeatedly initialized.
Yes.
So what happens to the old I? because we're copying values into the old
Yeah.
line.
So what happens is that we get to here,
Yeah.
and its lifetime ends. It gets destroyed.
Right.
Just as in any other occasion, we leave the scope of
existed
something.
and then it's
And then
reinitialization.
we jump to the top, and a new I is initialized. So it's as if we were creating it inside the body of a while loop, or of an old-fashioned for loop, a 3-element for loop.
Would this be slower than normal for loop then?
No, it's absolutely not. It's, you can look at the, so there's a website out there, it's called Compiler Explorer, or people call it Godbolt. So the website is godbolt.org, and it's absolutely brilliant because it will show you the actual generated machine code for your program. Godbolt, Godbolt.org. And it will show you like the Intel assembly for your program, which
Or
like,
or MIPS.
or whatever processor you choose to run it on. But I mean, I don't speak that. I don't really understand what it's doing. But what I can see is that it doesn't matter if you write it like this, or if you write it as a 3-element for loop, or even if you write it as a while loop, or even you can do it with goto. The compiler is so smart it will generate the exact same machine code. So Godbolt is absolutely brilliant for showing you like how clever the compiler is at optimizing your code.
So one thing as well, if you just start up Godbolt and turning optimization isn't turned on, you'll have to put it in the box for arguments like -03 or whatever. In this particular case, I would almost bet you that it actually unrolls the loop and just prints 1, 2, 3, 4, 5 to see out.
Yeah, in fact, this loop is so simple that the compiler will probably look straight through it and go, okay, I know I've got 5 elements, so I'm just going to put 5 for scenes in a row, right? The compilers are incredibly smart.
That's very annoying. We are the smartest.
That's what we make compilers, they're not made by robots.
Not yet.
Yeah, so half the time I try things on Godbolt, I have to jump through hoops to get it not to optimize things so that I can see, like, yeah, anyway.
If everybody wonders if Oli lifts his hat, there's like AI there.
It's not hiding in.
So just finally, while we're talking about loops, break and continue. People know what these keywords do. Well, first of all, let's talk about break. Does everybody know what the break keyword does? No. Oh, that's very honest. So, pretend though.
Yeah.
Just to get me to explain it. So what break does, if the word break appears in the body of a loop, any of the 3, 4 sorts of loops we've looked at, break immediately leaves the loop. So we see break, if it sees break, we immediately jump to after the closing bracket.
What happens if it's nested loop?
That's twice now. You go on.
Sorry.
I'm going to get to that. So you can only use the break keyword. Well, okay, you can use it in a switch statement, but you can almost only use the break keyword inside of a loop. And when you do it, control immediately jumps to the outside of the loop. Continue, another keyword. Continue in some sense, well, does the opposite. So break breaks out of the loop, continue continues the loop. It says, don't bother executing whatever follows in the body, immediately jump to the end of the body. And at that point, we'll jump back up to the top, we'll test the condition again, and we'll see whether it's appropriate to re-enter the loop.
We'll be able to update the incremental.
So yes.
To do the increment.
So yes, with a for, if you use continue in a for loop, it will do the increment step. Yes, it will. Yeah, that's very important. So break immediately leaves there and then. Continue goes to the next iteration. You can think of continue actually as jumping to the top, but it doesn't quite do that. In a do while loop, we test the condition at the end, and it does actually test the condition. I had to go and check that. I wasn't sure, but it does. But continue says, OK, I'm done. Go on to the next iteration. Break says, I'm done. That's it.
Well, more precisely, is continue says, check if we should iterate again.
So as Tom was just saying, in nested loops, so if we have one loop inside of another loop, which is, again, a fairly common thing to do, break and continue will only, will only break you out of the innermost loop that we're in. So I thought I had a slide that was demonstrating this, but apparently it's gone walkabout. So maybe I'll just draw it on the board instead.
If it's inside the
So
innermost
you
loop.
say it continues to
Yes.
Yeah.
first check the condition and then jump to the
No, it jumps to first or conditions.
first increments, then if it's a for loop,
It's forward,
jumps
just as you would if you naturally felt it bottom.
look for a while, you would just jump back to the top.
If I reach the end of my body,
With the while you want to
if I reach the end of
So
the benefit of everyone watching, you've written a while loop inside a while loop.
Tom usually takes photos of these
Yes.
things.
Tom will take a photo.
Yes.
Ah,
That needs to be
if you'll see
done.
that. I don't want to block the screen either. So we've got an outer while loop. So imagine I and j are like loop variables. So saying while I is less than 10. So for every I, we're going to execute this. We're going to do, oh, we might have to put plus plus j in there, say. And then we might do plus plus I down here. Otherwise, we'll just continue forever. What we do is we enter this loop, now we test some random condition. I've just called it blah because I'm lacking imagination today. But if this blah condition is true, we hit the break statement. The break only breaks us out of this inner while loop. Break doesn't come right down here, it just comes to the end of this. Okay? So break and continue is the same. For a nested loop, break and continue only operate on the loop that you're actually in, not any parent loops that you might. Oh, I forgot. Okay. So, this is all a bit kind of, especially for loops. 3-element for loops are a bit weird if you haven't come across them yet. So I think it'd be good to have a little bit of practice with these things. Somebody disagree? So square of a number is just that number times by itself, right? I don't want to assume everybody knows what I'm talking about.
As a quick point as well, if you do want to exit both of those loops, then as a matter of code organisation, put them in a function on their own and use a return. Then you'll jump out of the lot.
Yes. So basically I want you to do the same thing 3 times, but using 3 different kinds of loops.
Oh. See, someone uses .begin .end, the old style. If anyone needs any help, then just ask.
Yeah, so
Raise your hand.
So I'll give you say to later clock on this.
Basic would you consider to be to know fields in a class or a struct are initialized in the order of declaration.
That's it's not something everybody knows because people sometimes assume that they're done in the order they appear in the constructor initializer list.
Yeah, but let's just say that that's not the case. You've declared one in front of another.
Yeah, well, I mean, that's the way it's done.
No, but say you've got a header. So I have A, B, C,
Yeah.
and C is a type that's initialized with A. So I initialize it with this C. So I initialize A with this C
But
in
if
the,
they're,
in the header.
yeah,
So there's not even an initializer list involved.
okay. Well, that's not going to work, is it?
No, Josh, not on that. Yeah. How obvious do you think? No.
I don't think it's something that everybody knows.
No.
Um,
Something you've done after a few years.
oh, definitely. Yeah, compiler's probably. So you're talking about like in-class initializers.
Just in the header, yeah. Just having an inline class, no, not even a separate translation unit.
Yeah.
Yeah.
That's, I'm assuming this is somebody turned up at work.
I'm not saying. Yeah, funny that. Yeah. That's exactly what compiler does too.
So designated initializers are going to make it even worse for
Yeah.
aggregates,
Yeah, that's true.
but they should be able to warn about that as well. Are you coming to this meeting on the 29th? Get the email? BSI.
Oh yes, yeah.
Oh, just while I think about it, we're C++ London Uni. We're sort of a spin-off-ish from the main monthly C++ London meetup. And they're actually having their October event tomorrow in Paddington. So I believe there are still spaces left. If anybody fancies coming along to mix with a load of, people who do C++ for a living, then by all means come along. So you can go to meetup.com and I think it's just meetup.com/CPP London or something like that. But you can just search on meetup.com and you'll find it. And you can register and come along. I'll be there. Do you?
I expect to be there.
Yeah. So, you can come along and have a drink with us again. And listen to a couple of interesting C++ talks. So we've got Phil Nash. We'll be talking about his testing framework Catch, which he's done a session for us here as well in the past. So that should be quite interesting.
Yeah, the main event tends to have a sort of fairly complex set of subject material, which, if you're even intermediate or consider yourself potentially advanced of, it can be ridiculous. Not in a bad way, though. But I would definitely recommend tomorrow, just because we know Phil anyway. I think it's going to be a pretty accessible talk.
So, So that's what we want to. So we're doing the.
Yeah.
Range. That's what we need to do. Okay. That's what we want to make this function. And then we need to. So we need to tell the computer what sort of argument parameters we need. So we need to tell it that we want to
So I've only got to verify it.
Because it flips around.
That's the right.
So that was
And then we can call it whatever we like. Okay, so now we're saying there's a function called print squares, and it takes an argument of standard vector. And what kind of type is this function, or what should this function return?
it was fine on the visual studio.
Yeah.
This function doesn't need to return anything. All we're doing is using this function for Tristan. So this function doesn't need to return anything, it's not got any value, it needs to give back. So in that case, you can just say return nothing. That's a special word. So now we've said, okay, we've got a function called print squares. We're going to give this function a vector of doubles, that's a collection of doubles, and we're going to return it. So now we've got a brace there and another one there, and then inside this is the body function. So this says, what does this function do?
It just gives you the machine code that the CPU runs. It's not really quite nice. It's just like you want to figure out how I written a reasonably fast thing.
So that's basically
Although, to be honest, if you put a load of code into it, probably try and find it.
Yeah, we haven't used
a lot
it.
of machine code to look at it like that.
So it's going to complain about this for a minute, we're going to change that in a second. So this is for every D, every double D in our vector. So vector is a collection, and now for every collection of doubles, so for every double in that collection, we're going to do something. What we're going to do is print D. Those. So now we've got a function called print squares, and inside of this, every double we're going to print. So this is exactly what a library is.
So for the brackets, like for number,
Also, he's trying to do.
number.
So for part
Here's where I use
No, it's not.
Oh, right. No, it's not. Do I well, so you just do right.
this is
Use the carrot.
the way this works is every time we go through the loop, it creates a variable called D, and it initializes
built into doing the link like something from square.
I'm lying, I'm completely lying. It's not carrot, that's an XOR operation.
So the first time
sorry,
we go
yes.
through, D will be set
That's
to
a little lie, I'll XOR it.
first one is in there.
How, I can't remember which header you have to include. It's with how. It won't be a second find it.
So we've gone through every element in our vector. At that point, before you need to leave the loop. So this is like sort of handy shorthand.
See now.
One of these collections. So vector is a line graph of this one.
Okay, I see it, yeah.
No.
So you don't have to
So I don't even need to create double square. I can say
you don't have to worry
But I thought this was how I read some other language. I'm sure about it. I read somewhere. I think of image
yeah, because I mean that was fantastic. Just to that was just linking, and it was just minutes equals later and no, it's only maximum. I'll show you. Just building. Literally, it's a matter of it works with the much smaller that's interesting. I did like double. I don't know why. Some of the test problems double max. No, which is why here min is 2.5. Oh right, the minus 3.
You have no guarantee that negative double max is in range. I would just
yeah, well, I didn't know about that.
Oh, okay.
yeah.
I didn't know about that, to be honest. I Google stuff and get Stack Overflow.
That is definitely not valid. There is no guarantee that the maximum value will be just a negative legitimate reason value.
Well, I did check that. It does actually. It does actually say the same number
When you're working on it,
yeah, it could be.
I know why, because here I have it. I added the points.
yeah, it does not really work on the it's terrible for that.
I'll tell you why.
It's again STD.
Numeric limits.
So you set
So I would just use it. So if you want to be super duper pro, a numeric limit has infinity function or boost.
So what's happening here is this is creating a
And then minus infinity.
And you can just negative. No, you just make it negative by 50 double.
Oh, okay.
this should be that
But if you want to be super correct, there's a function you can. It's not a function or value, but it all has infinity in the center true, and infinity exists in your.
I'll have to look out. The thing is, you get these problems, and I know it's C++, loads of ways to solve problems, isn't there? So you go on the Stack Overflow, you Google it, you come up with solutions, and there always is another one.
It's very small. I don't know how to get bigger.
But if it was in order to return something,
Then
Yeah.
Whereas if you don't expect, it doesn't. So the best you can do that is just the biggest possible number.
Yeah.
And it has values for that. So use max.
so the first one is for
Your highest and
yes,
lowest.
okay, yes.
Yeah, not high actually. High.
Just lowest. You said lowest.
Max is
So I need to look that up.
lowest.
It's one of those things you need to remember.
Yeah, min is just the tiniest positive value.
Oh, it's finished.
That's painful.
Can I ask you something super quick, don't related? The previous exercise, because I wanted to start on this.
How do you get on?
I just want to make sure the way so if you have done it on my same time, so you might not see it here. Simply on this
Very nice.
test. And then in test that I got in my
You can do everything with that.
yeah, we cool down the Google.
And you
And then I
should
get next yeah.
That's actually
Is that
that is really good, yeah. In fact, so what I was doing in your maintenance is, if I'm doing something like release publicly, I usually stick an option around it. So if some user control option like enable testing. Then I put in the subdirectory that way. If you don't care about running like user fix, they don't have to worry if they want to build it.
And the way you run it is by simply because I wasn't I was actually running like this CD to my special library, but then I noticed that I should turn it off. So it's instead
Okay. It's 5 past, so we still got a bit to cover. So if you haven't managed to do those and you want to continue with it, then close your ears for the next few minutes. Otherwise, I'll quickly run through the solutions. So first of all, obviously we're printing something and we're using vectors, so we need to include the appropriate headers, standard library headers. So first of all, I've called it print squares 1. I've got the range 4 version. Oh, it's print squares, wasn't it? Silly me. Let's try that one again. I'm not doing very well with my code tonight, am I? So for our first version, we declared a function, takes as an argument a vector of doubles, called it vec, returns nothing. So this is a range for loop, so for. What does this do? Auto D.
Deduces the vector. Deduces the type of vector.
Exactly the right word. It deduces the type of the elements of vector. So it initializes D to whatever type would be appropriate for whatever the vector's holding. In this case, the vector's holding a double. So D is going to have type double. That's going to be deduced from this.
You also do const auto.
You can also do const auto, absolutely. And that works because we only initialize this. We initialize this every time we go through the loop. So yes, const auto would be even better there. So I could have written double. I just want to remind you that the auto keyword exists and want to show that you can use it here. So for every element in the vector, we create a temporary or a variable called d. To hold that element, we print out d times d. Print out the square. The point wasn't really about printing the square, it was just using the loops. So who managed to get something like this for the range 4 version? Yeah, quite a few of you. Good, good. What about the traditional for loop, the 3-element for loop? Oh, most of you as well. Excellent. Okay, so this time we do is we first of all initialize this type. I used an int, which is not strictly speaking the correct type, but it will do for us for this purpose. For these purposes, we'll use an int called I, and then we immediately check, is I less than the size of the vector? Now we could. 0 is a perfectly fine size for a vector. You can have a vector with nothing in it. So we could have been given a vector of size 0, in which case, is 0 less than 0?
No.
Okay, so that would be false and we'd never execute the loop. So this is fine for vectors of size 0. So we start at 0, we check whether that's less than the size, and then if that's true, we execute the body of the loop. So this vec with the square brackets is accessing the element at index I. So remember, C++ counts from 0. So element 0 is what in conventional speech we'd call the first element. We do this, and then we do this post loop step. So plus I, so I was 0, it becomes 1. We test, is 1 less than the size of the vector? If it is, we do this again, and we access the element at position 1. And so on and so on. Until eventually I is equal to the size of the vector, in which case it's not less than. And so we skip over and we carry on with the function, which actually has nothing else in it. So again, hopefully people got something similar to that. And then finally, our third version using the while loop. So this time I've initialized this variable I by myself outside of the loop. And now I'm testing, is I less than vec.size? And if it is, I print out the square. And then I increment I. So you can see that what I've written here is actually identical in code terms to what's happening here. First of all, we're initializing I, then we're testing the condition. If the condition is true, we execute the body and increment the value. I've written I++ instead of plus I, it doesn't make a difference in this case. And then we test the condition again and again and again until the condition is false, in which case we carry on.
What if you incremented I on that second vec? So you did vec I++.
That would be fine as well if you really wanted to be a smart ass about it.
AI.
Or would it actually? Oh, I don't know.
That's what I asked.
Order of evaluation.
Yes. I'm not sure.
Because it changed in 17.
Fine.
17, didn't 17 guarantee left to right evaluation?
No, there was a paper that I think got pretty much thrown
Oh,
out.
okay. Well, anyway.
That's what I was getting at. Yeah, I think
Oh,
it's fine.
Well. So yes, any for loop that we write like this, we can translate into something like this. And in fact, if you are a very boring kind of person like me, and you read the C++ standard, it explains how a for loop works. And it says, when we have something that looks like this, translate it into something that looks like this. Do exactly this transformation that we've just done. So every for loop, 3-element for loop, is the same, is equivalent to a while loop written like this. And we can go further, and in fact, it's a little bit more complicated, but you can rewrite a range-based for loop as something like this. It doesn't actually use size, it uses something called iterators. But every range-based for loop can be rewritten into an ordinary for loop, and every ordinary for loop can be rewritten into a while loop. Believe it or not, there's one more step after that, because you can rewrite a while loop using the goto keyword, which you should never do, but that's technically how the standard defines how the while loop
Which
works.
loop should you use as a professional developer?
Which one should you use?
Yeah.
You should start at the top, and if this one's appropriate, use this one. If it's not, use this one. If trying to do it as a for loop is kind of horribly complicated and you need to break and continue and you need to test your condition in different places or whatever, use a while loop.
So the while loop is like the least favorite.
Yes. Do while loop is actually used even more rarely than while. Do while is very rare.
I would point out, though, one caveat to the top one is that you don't necessarily realise you're operating on what are called iterators, the begin and end. And previously, when you explicitly were having to use them, you'd read the documentation that says what you can and can't do, or what might invalidate them. So as an example, when you operate on a vector, say inside that top for loop, I add an element to the vector. Now my iterators, all those internal ones that the compiler has generated for me, are completely invalid, and I actually need to exit the loop immediately.
Yeah.
You don't necessarily realise it when you're doing that stuff. So essentially, when you're iterating over stuff like vectors, don't modify the vector. You can edit the element itself, but don't
Yeah.
add or remove elements.
That's actually quite an important caveat. So this first one, if the body of the loop involved modifying the vector in some way, you wouldn't be able to use that. This second one, if the body of the loop involved adding things to the vector, that'd be all right, because by the time we get back up to check the condition, the size would have changed and we'd still check that appropriately.
What can happen that you could skip an element by doing that? Let's say that if you remove, if you saw your for loop, you remove an element for your vector, then you're still looping on that. On which vector are you looping?
Sorry.
So let's say that you have a vector of.
Are we talking about this one
No,
here?
the for loop, the second one. If you have a vector of size 3,
Yeah.
and doing the first iteration, like when I equals 0,
Mhm.
first loop, you actually remove an element from your vector.
So now I have size 2.
So the size is 2.
Yeah.
Okay.
So then when we come to check, it's going to say, is 1 less than 2? Well, yes, it is, so we'll execute the loop again.
If, however, you put vector size in a variable above that, then yeah, you probably crash because you cached the value and didn't pass it every time.
So yeah, when using this first form, it's very simple and very handy, but it can go wrong if you modify the vector whilst you're iterating over it, whilst you're looping over it. So if you're doing that, then it's better to use a different form of loop.
If you're doing strings and characters, a special character for carriage return or something, will that mess it up?
Well, carriage return /n is just a single character in C++.
Okay. So if you had /n in your string,
It would be fine because it's treated as a single character. So what's called a control code.
Sorry, so you know how you said that the first one's not appropriate if you're modifying the vector? Will it give you an answer or will it just come up with an error?
Most likely it will just crash, which is rather unfortunate. If you're very lucky, the compiler might say you're modifying the value, but it probably won't. So yeah, for safety, I guess a really safe way of doing it is only ever use this form if the thing you're iterating over is const. Because if we'd said const, standard vector of double here, then we wouldn't be allowed to modify the vector. Any attempt to modify the vector would be an error.
But can I ask you something?
Yeah.
When we have a function like that, this vector is the vector or is a copy of the vector?
This is a copy of the vector. Yeah.
So we want, even if we modify, we want to modify the original.
Correct.
But what about the back inside the for loop? Is that a copy of the copy or not?
In here,
Yes.
so when we enter the function receives a copy of the vector,
Yes.
right? Because we're passing by value here.
Yes.
We don't copy vec again. So vec itself, that is the whole vector, is not copied. What happens is that each element of the vector is copied into this new variable d. Now again, for something small like a double, that's absolutely fine. If we had some very big thing in here, if it was another vector, if we had a vector of vectors, which is something that it's perfectly okay to have, in that case, we probably wouldn't want to copy each internal. Probably wouldn't want to create a copy of each element every time we went through this loop. And in that case, it would be more appropriate to use references, which, as it happens, is what I'm going to go and talk about right now. So that was a good, timely question.
Can I ask one question?
Sorry, go on.
The vector dot size, does that value get cached or does it reevaluate that every single
It reevaluates every time. That's a very good question. Yes, it reevaluates every time we come to this position. Yeah. So if in this form of loop, if we did change the size of the vector in the body, then when it jumped back to the top to check the size, it would have updated. So that's why this is a lot safer to use than this form if we were changing the vector, modifying the vector in the loop. So yeah, that's a very good question. Yeah.
Can you provide an example where one of the three placeholders in the second case is left empty in a for?
Well, I can. Where one of the placeholders is left empty, I can in fact go further than that.
At least one. Or zero. Oh yeah. Okay.
Something. So this, doing for and then just a pair of semicolons, is fine. right? It's not fine. It's a perfectly legal thing to do. And what this says is do this forever. So there's no initializer, there's no increment step, there's no post-loop step. And if we leave the condition in the middle blank, it's as if it returned true all the time. So this says loop forever.
So you need to include a break.
So you would have to have a break in there, otherwise this would. Yeah. This is pretty obscure. Like it's people do this, especially C programmers. I find this a bit kind of unpleasant. If you want an infinite loop like that, I would suggest doing it like this. So while true, that to me is far more clear that this is an infinite loop. Because it's while true.
Tristan,
yes.
Question for the range loop. How could you make sure it got correct constness? Yes, like so basically as many const we could put there.
How const can you make it? Right. Yeah. So first of all, we could declare our function parameter as const if we wanted, and that would prevent us from making any attempt to modify the vector in the loop. So that would be safe.
The parameter would say const standard.
We could also have const auto in there, or const double. And that would prevent us from modifying D within the loop. So I can't remember who was it, somebody said, can you use const? And yes, you absolutely can with the first form.
So we could use in a parameter const standard vector double vec. Then we could use const auto, const D.
No, just the one const.
Yeah, you can.
You can.
That's okay. Yeah, it says. So I was trying to be too smart. Sorry.
So yeah, this is recreated every time we run through this loop. So if we make it const, that's fine because we're not attempting to assign to it or change it in any way after we've initialized it. Is there any more questions about loops before I go on to yes?
The caching for the for-range loop, how does that actually work?
Caching.
Yes.
What do you mean by?
As in, so it sort of takes the copy vec that's passed into the function, and then it starts the for loop.
Yes. So what it does is it initializes a couple of hidden variables, one of which is what's called an iterator. That is, it's like a special kind of variable that there's like a special kind of index into the vector, right? And every time we come down here, it increments that index, and then the terminology is dereferences it. That is, sees what that element is in the vector, what lives at that index, and then it assigns that. It copy constructs D from that element. So if you really want to have a look, there's cppreference.com. Tells you exactly how this range for works and how it gets transformed into a standard for loop. And then it goes on, it does all these three transformations.
The basic principle is that you ask the vector to give me the beginning, so it gives you an iterator at the beginning. It doesn't track that iterator. That iterator is basically just a pointer to the memory where your stuff is.
Yes.
And then you go inside the loop, you still have the iterator object, and then you add an element to the vector, but the vector's not big enough, so it reallocates. It goes and gets some memory over here, copies everything over, and then releases the old location, but your iterator is still pointing to this place, not this place. So when you then try to use it again, you're just going to try and access dead memory, and then boom, you crash.
We'll get there.
And that's the place when you can see unicorns.
Someone's staring through the door. Okay. I mentioned this at the beginning, but we'll go over it very quickly again now, because we're going to talk about references. But first, I just want to make sure everyone's on the same page about value semantics. This is something we talked about last week, something that's very important in C++. And it's, again, as I said, probably a little bit, well, perhaps a little bit different to other programming languages you might be used to. So value semantics mean that copies of values are distinct. When we copy a variable and we modify the original, the copy is not affected. Or to put it another way, if we copy a variable and we modify the copy, then the original is not affected. Right, so a good way of thinking about it is like the files on the file system on your computer. If you copy a file, say a Word document, and then you edit the original, the copy is not affected. Right? Copies are distinct. That's value semantics, or one aspect of it. To give you an example, we initialize an integer a with value 1, and then we'll create a new int called b, initialized with the whatever value a has, which in this case is 1. So now b has value 1. So now we change the value of a. We set a equal to 42. So what's the value of b now? At this point, what's the value of b? 1, exactly. We've changed a, but they're independent. B still has value 1. So for most programming languages, this is quite familiar with for built-in types, fundamental types, whatever you might call them. For C++, this is also the case for most class types. So standard string is a class type. So I've created 2 strings, s and s2, initialized to hello and world. And now I'm modifying s. This plus equals for strings, it performs string concatenation. So s has the value hello world. That's the 2 strings glued together. But we haven't changed s2. This doesn't affect s2 in any way. These are independent variables. And I thought there was a bit more to that, but apparently that's it.
It's the same for the vectors.
It's the same for vectors, yes. Yeah. So, yeah, every class in the standard library works that way. Uses these value semantics. And value semantics are brilliant because they allow us to reason locally about our functions, right? So, if the examples we've just seen, for example, because we're passing by value, we've received a copy of whatever that gave us. So we know that whatever we do to that vector that we had, or an int or a double or a string or whatever it might be, we know that that's not going to change some other part of our program. And it's particularly important when we get to talking about multi-threaded code, because in that, when you're in the multi-threaded world, you don't know in what order your operations are going to happen. But if you take your parameters by value, it doesn't really matter which operations happen before which, because you know you're only operating on a copy, right? So it allows us to write what are called pure functions. Functions that don't have any side effects, don't read random bits of memory.
Idempotent, I believe, is the...
Idempotent,
Yeah.
if you like. So value semantics are really, really brilliant. But there's a downside to them. Anybody think of what the downside might be? To pass by value, sorry?
Use a lot of memory.
Uses a lot of memory. Why does it use a lot of memory?
Meaning a copy every time you pass things.
Yeah. So the downside is that, let's say, we've got a vector with 10 million things in it. We call a function on this vector, that is, we pass it by value to this function. That's going to create a copy, a new vector with 10 million elements in it. And then when we leave the function, it's just going to throw that copy away. Copying something with 10 million elements takes time. And in C++, we're really focused on performance, right? We're addicted to it. And copying things unnecessarily, we don't like it. So value semantics, incredibly useful, but can be expensive, particularly when we're using arbitrarily sized things like a vector. Copying large amounts of data for every function call is potentially slow. Doesn't have to be. I mean, if we're just using a double or an int, those are very small, a few bytes. Copying that takes literally no time at all. But for things like strings and vector that can be very large, there's a downside to passing by value. So for this reason, or it's one of the reasons that C++ lets us opt in to using what are called reference semantics. It's in some sense the opposite of value semantics, reference semantics. And references are also, well, they're not needed. Needed is probably wrong. Useful would be a better way of saying it. References are also very useful for object-oriented programming, which we'll cover later in the course, or some people have already sat through all that, but yes. Yeah. So let's have a look at references. So we declare a reference, create a reference in the same way that we create any other variable. The only difference is we put this little ampersand, this and symbol, after the type name. So this first line declares an int called I and sets it equal to 0. This second line says I want a reference to an int, which I've in this case called ref. And I've initialized this reference to point to this value, to this variable I. So when we create a reference, we always need to give it an existing variable. And you always need to initialize a reference. So I said it's always a good idea to initialize your values, your variables, because if we were to leave that bit off, I would just be filled with random junk. If we try to omit this bit, we wouldn't be allowed. The compiler would complain. The compiler would say you can't have a reference that doesn't refer to anything. That makes no sense. So the way to think about references, C++ references, is it's like a new name for an existing variable. So I've created an int called I, I've created an int reference called ref, and I've set ref to be the same as I. So now if I change I, if I set I equal to 42, and then I try printing ref, it's going to print 42. And if I set ref equal to 99, and then print I, it's going to print 99. Anything we do with the reference affects the original variable. Right? A reference is like a new name for an existing variable.
Like a shortcut.
Like a shortcut, if you like. Yeah, kind of. So, yeah, so to use the file system analogy, or think about Word documents, right? If we were to open the same document in 2 windows on your computer, and then you edit the document in one, as soon as you save, as soon as you commit to those edits, the other window, hopefully, will update to show you the changes, right? It's like having 2 names for the same document. 2 names for this same bit of memory. The memory in which I is stored, we're now just having a new name by which we can access it. So this is completely the opposite to the value semantics we were talking about. Value semantics copies are distinct. With references, they're the same, it's the same bit of memory as the original variable. It's just a new name for it. I is an int and an anint. Yes, well, anyway, never mind about my English. Just as we had on the previous slide, I is an int, right? So this first one, hopefully completely familiar, that you've seen many, many times now. Now we're declaring this second variable called ref. And the type of this variable, we read it from right to left, is reference to int. And we initialize it, we say it's pointing to I. So now we say ref equals 42. Well, ref is just a different name for I. So if we say ref equals 42, that is what we're actually doing is changing I to 42. So after this, I is now equal to 42. And now let's go the other way. Let's change I. We'll say I is equal to 24. I'm now going to print out ref. So what is this going to print?
20.
We've got two choices, right?
Yeah.
24, 24. Who thinks it's going to print out 42?
36.
36. Yeah.
It depends where the line is.
Infinity. This is going to print 24. Everybody who said 24 was right. Right, because ref and I are just two names for the same variable. So anything we do to ref affects I, anything we do to I affects ref.
It's an alias, another name for the same thing.
So here's a tricky one. What am I doing here?
Creating another alias for I.
Brilliant answer, completely correct answer. I'm creating another alias for I. Okay, so I'm creating a new variable, it's called ref2. Ref2 has type reference to int. And I'm initializing it with ref. Well, ref is another name for I. So ref2 is yet another name for I. So now we've got three names for the same thing. And it doesn't matter which I use. I or ref2. Now, you're probably looking at this and going, well, this is, how on earth is this useful, right? Why do I want to give another name to something that already exists? Because I could just replace every use of ref with I here and it would work exactly the same. What's the point of this? Why? And the truth is, there is pretty much no point in declaring a reference in the same scope like we have here. Why this is useful is because we want to use it to pass by reference. So, last week and earlier on, C++ uses pass by value by default for function calls. Meaning that when we take an argument by value, it will receive a copy of whatever we give to it. But we can use these references, these new names for the same thing, to use pass by reference. That is, we can pass the function the actual variable, not a copy of it. It means the function will operate directly on the argument that we give it, not on a copy. So, here I've got function signature. The name of the function is say hello. It returns nothing. And it takes a single parameter called name. What's the type of name?
String.
Reference to string. Yes, absolutely. Well done. So this is an example we had a week or two ago. So in that case, we took our argument by value and returned a new string. In this case, I'm taking name and I'm modifying it by putting hello and a space at the beginning. So whatever string we were given, we're going to put hello at the front and set name equal to that. And that's all this function does. It prepends hello to the start of the string. So now let's imagine this is in some other function. I'm going to create a string called me, set equal to Tristan. And we're going to call say hello with me as an argument. So when we call this function, it's going to initialize this parameter as a reference to this variable. That is, as a new name for this variable, me. So when we modify name here, because it's a reference, it's going to change this parameter. So we're no longer operating on a copy. We're now operating on the argument itself. So when I print out me, what's it going to print? It's going to print hello Tristan. Because this function say hello operates on a reference. So when we pass this thing by reference, we're actually changing the variable that we give it. We're no longer operating on a copy, we're now operating on a reference. We're operating on this actual value here. So it changes the argument that we give it. So we've got two different ways of passing arguments to functions in C++. We can do it by value, in which case we'll get a copy, or we'll do it by reference, in which case modifying the argument will modify the thing that we gave it. Yes?
This is like a best practice question, but like when you have a reference, and I'm guessing like eventually when we go into pointers, is there like a way you should name your variables so you definitely know it's like a reference versus, you know, saying our name instead, you know?
Inside the function,
yeah,
you always know the type of your variables because it's right there in the... So I would say just name them whatever is natural. I mean, some people do go with like Hungarian notation, so they use P prefix for pointers and R and M for member. Personally, I keep my functions short, and that way I've got the arguments and the whole function body on the screen at once, and I can see, I know exactly what every variable in scope means. If you've got these huge 1,000-line functions, yes, it can be a bit more tricky. But
Tristan, I'm just playing into constants, trying to
yes,
get into the habit of using it. With this example, I don't think there's anywhere I could really put the constants.
we're going to talk about const references. Well, we won't get to it today, but we are going to talk about const references because they're a bit special and a little bit different. So this is just dealing with what we call mutable references, first of all.
Okay.
But if you're wondering, had I declared me as const here,
Then I wouldn't be able to add to it.
yeah, so if we declared it as const, that means we can't change this. So if we tried to pass it to say hello, it doesn't even need to know what the body of this function does. It only needs to look at the signature and it will say, well, this function might modify the value, so I'm not going to let you pass a const thing into it. Right. Doesn't matter whether the body of the function actually modifies it. It won't let you pass the function.
Quick
Yeah.
question related. Functions, in the actual function itself, do you need to give the variable itself a name at the top with the type or no?
In here,
Yes. Do you need to?
you could omit that if you wanted to.
But then how would you call it?
You can't use it. It's
You,
unusable.
you wouldn't be able to refer to this inside the function, so it's not a very useful thing to do,
That's what.
but it's legal. And there will still be that variable created.
Waiting around.
Yeah, you just won't be able to do anything with it.
So just a quick note on the best practice question. There's a school of thought that taking references and then having the function modify them is considered sort of bad form. I'm not sure that's definitely not universally true, but I would usually say that when someone looks at the name of your function, they should be expecting an argument to get modified. So if you pass an argument, it should be obvious from the name of the function, preferably, that it's going to modify what you pass it. Because obviously it's very surprising if you call a function and all of a sudden your object's now totally different. So
A better name for this function would probably be prepend hello or insert or add hello or something like that. Because
Read only hello.
say hello doesn't really describe what this does. I would expect a function called say hello to print something. Right. So the only reason I named it say hello is because we actually used this as an example of value semantics before. So I thought I'd just recycle the same. But we've got 13 minutes left. So I reckon you can have a go at this and then we'll quickly go over the solution and then I'll leave you with a second exercise to do in your own time. No, that's been there a couple of weeks, well, a couple of months in fact. I've been quite tempted to,
yeah.
because that would actually be quite useful to me because I've got a lot of Australian electronics.
Yeah. Well, yeah. Nothing occurred to me. How basic do you think it would be to know that an initializer list, right? It's an initializer list, right? After a constructor,
Mm.
so a translation unit, declare the constructor, not define the constructor.
Yeah.
Arguments, colon, initialize them. Members.
Yeah.
Fairly basic thing.
Constructor initializer list.
Isn't it? Yeah, that's the term.
Yeah. Yes. That's, well, I covered it when I covered constructor. Yeah, that is constructors 101.
You think that's fairly basic, wouldn't you? You'd kind of
Yes.
think someone could know that.
supervision. You know, my favorite setup is like one customer sits on the right, the other one on the left, and they keep asking intermediate questions. The first one asks one question, answer the another one. And you have to do it at the same time sometimes.
And just to try and sell these, well, promote these a bit more. They come with the latest and greatest compilers. It's got C-Line pre-installed, and of course you can.
Doesn't have a license.
You will have you need to log into your account. You log into your C-Line account, of course. But it's very convenient. You can plug it into your laptop and then unplug it and plug it into your PC when you go home and carry on working on your home PC on the stick. So it's quite nice for that. And you don't have to set up an environment.
I think we're doing it in the wrong way. We should do it like, you know, these people with the cards, you know, the first person, you know, I will go and I will buy them for like 50 and say, oh, that's bargain, and everybody will jump and will buy higher.
Or you could do the old, you know, some cups with the sticks and then say, who can guess where the stick is? And then they can never guess
another
and
one.
just keep on.
The only problem is I'm horrible. I would lose them.
Or if you want, I suppose what we could do is if you want to try one, then we'll take the money as a deposit, and you can come back next week. And if you decided you didn't like it, we'll give the money back.
2-week money guarantee.
Gosh, you know what we're really going to do? As soon as we sell one, that's it. That's it. It's all over.
Strictly limited edition. In a way, I mean, I got to work.
Just find out if you're rushing.
It's all elaborate routes to get someone to try and do it.
Someone here works at the government.
I need to go back.
Have you heard of this new phishing?
It's not obvious.
They get your data, let's say they found something, your login name and password. They email a user, and on the first sentence they say, oh, by the way, your password is, and they provide a response.
No, just
Yeah.
so exactly what it says there. Just try when you've written your increment function
Yeah,
with the
they're
reference.
phishing
Yeah. So the mistake is before.
So that's the work. Inside the curly bracket
Does it
is
go
the work. Your function.
That's what I want to do.
And the title is what crazy. So you're not returning anything. That's what you avoid. It's called increment.
Okay, so that was
And
actually
you're
the last
passing
part.
I into it. To do work on the I.
The third one.
So what you do now
I was
is
asked to
you
just define.
Tristan,
Essentially, I was saying that to define.
you can only have one function. So you need above your name.
It's not obvious.
Because that's where it's supposed to read down the page. So if you get to your main,
Usually speaking.
yeah, well, I mean, I've done it. I've done it. As long as you have your main.
That's right.
This.
And just put it above the main.
First, if I write something, I mean, I know that we haven't. The trouble is when we get two brackets, so this bit is exactly the same thing.
So that comes out.
When you do I++,
Inside your main.
What happens when two you can't give another name. So we tried to change the name to
So here, you need to define that's calling increments. Saying those increments. But you need to pass a value. So above that, you need to define
it's going to do
will be
is not going to change.
it could be anything. Underneath that, you need to send that.
So this will change.
You just type
Or you could put it on the right.
just type in auto.
Yeah.
It's like you're phoning in and you're passing. You mean exactly like that?
That's where
No, it's not.
so it's the same like so how
You may not.
And that will work.
But I might be wrong.
Sorry.
Guys, 5 more minutes. We'll need to thank you
So absolutely.
It means console out.
So when I first wrote it, I put this condition in the CR stage to send no.
You could do because
It says, oh, I can't understand.
When you were the tummy now,
Okay, so I'm just very quickly, because we've just been given the hurry up by our hosts. So I'll just very quickly show you a solution to this. So our increment function takes as an argument a reference to an int, which I've named I. We increment I, could have done I plus equals 1, or many ways to do it. I just do plus I. Then in main, we create an integer value, val, initialized with 0. We increment val, and now after we've called this function, so we pass this function our variable val. This is a reference to val, so it's a new name for this same thing here. We increment I, which is the same as incrementing val. And at the bottom line, I print out what val is, and of course, because we've changed the reference to val, same as changing val, it's a new name for this same variable. So of course, this prints 1. This magic line above it, this is a special function, well, technically a macro, called assert. And the reason I just wanted to show you this quickly while I was going over, while I wanted to go over the solution just before we go, is assert, for which you have to use this C assert. It's not cassert, it looks like cassert. It's C assert because it's part of the C standard library. C assert header gives you this access to this assert function. Assert is really, really useful for debugging. So what it does is it checks, you give it some sort of Boolean condition. So in this case, val equals 1. And what it does is, if this is true, it does nothing at all. If this is false, it crashes your program there and then. And it tells you exactly where, which line, in fact, even which column, and the condition that failed. Right? So it's a really useful debugging aid. You check there's something, this must be true at this point in the program. And if this thing is not true, I have a bug in my program. So crash right now, and and if you're running it in a debugger, you'll be able to click and see exactly the value of all your local variables, all that sort of thing. Assert is really, really useful. And what's even better is that when you compile your code in release mode, the assert statements completely disappear. Right? They literally do not appear in your source code anymore. Right? So assert is absolutely free in release mode. It has no overhead whatsoever. It's really, really useful. It's a very blunt instrument, right? You've got one of two things will happen. Either it'll be fine or your program will crash. So it's a very blunt instrument, but it can be very, very useful for debugging purposes. So that's why I wanted to very quickly show you that. So I highly recommend using asserts in your code.
I never use assert, ever. I do unit testing, and in the worst case, when something really ridiculous is happening, I might print some stuff to the console, but I literally can't remember when I last used assert anymore. I just use unit test.
Can you use it just in debug mode?
Sorry?
Can you use it just in debug
The complex answer is, strictly speaking, no. You can force it to be turned on in a release build by defining a macro value, but you probably don't want to. The idea is that it's in your debug builds you want to catch stuff going wrong. In your release builds, you're just going to annoy the users if you just immediately crash.
Right, so this isn't the proper homework. This was going to be had we had a bit of time at the end, which we haven't. We've, in fact, ended splendidly on time. So if you want to take this away and have a go at it, that's great. I'll also, when I put the slides up, put a bit slightly more involved homework as I have done in the past couple of weeks. Probably not as involved as last week. I might actually do the solution before I... but anyway, again, it's just to give you a sort of a bit of practice with using reference arguments.
Come on Thursday and we can work on it all together.
Yes, absolutely.
Exactly.
Come on Thursday in Costa.
Yeah,
Right.
Unless our website states otherwise. Yes, there's few workshops which we managed to book in Skills Matters. They will happen normally by the bar. They give us one table, but otherwise, because they're very busy, I think we will try to be consistent, make life easier for everybody, and move to Costa. Okay, thanks very much for Tristan and Oli for their effort. Really appreciate it, and I encourage everybody to join us in pub.
All right. Thank you very much, everybody. Cheers.